Hello again, Mr. RG Stuff here in the workshop. Now sometimes videos get away with you, and this is one of them. I was all ready maybe a couple of weeks or so ago to film this, and I had it all out on the other bench, but I had some technical issues and I've had to move over to this bench, so it's all going to be a little bit different. Anyway, I've done various bits and pieces, so I'm just going to talk about the various things here and what I'm trying to do. Now you may have noticed from some of my other videos that I like old gramophones and old 78 records, but one of the problems is that they only last a few minutes each, so it's impossible to do anything whilst listening to them other than maybe select the next record to listen to. Now a couple of years or so ago I had an idea to build an MP3 player into a sound box instead of having the sound box actually have a needle and actually take the sound off the record. And this is basically what I've got here. This is my test rig. And just very quickly, I've got these little boards here. These are actually the MP3 players. And these are DF player mini boards. At least this one is marked so. The other two are actually marked MP3-TF-16P. I've had this board here that I've got marked A for a couple of years, although only very recently have I actually tried to use it, and it works fine. I've had it working, no problem at all. These other two boards I bought recently, and well, they work to an extent, but clearly they're not the same. Not all the functionality is the same, and that's caused me a lot of trouble trying to get the software on the Arduino to actually work with all three boards. And to be honest, it works with two of them, but not the third. And I may go into detail in a future video as to the ins and outs of using these boards, but certainly the various forums on the internet are full of people who are struggling with these sort of boards. Some people can get them to work fine, other people absolutely no luck at all. Anyway, got a board connected up to an Arduino, connected up to a speaker. I do have some buttons on this board here, but I'm not using those, and I've got a couple of spare boards there. So what I need to do is take one of those boards and an Arduino and actually fit it into something like a sound box. And I 3D printed this sound box back here, or in fact front to be more accurate. I already have 3D printed sound box backs. This is one that I used in a previous video. So basically it's a piece of 21.5mm waste piping as used in the UK and maybe other countries. I've slit it. I've inserted a piece of copper basically to reduce the inside diameter a little bit, and also it's sort of adjustable by squeezing the copper. And then I've just cut another piece of piping, cut it there as well, heated it up, wrapped it round, glued it in position, and then I've drilled a little hole which is about 4mm from the edge, and screwed in a little screw which I have filed the end down into a peg, and that becomes the locating peg on the tone arm. And this just sort of clips on, and I put in little M3 screws, and that will fit on a gramophone like so. Now you've probably realised that there's no way that that Arduino is going to fit into this. So clearly I need a smaller Arduino, and I'm going to use one of these, which is a Nano, and that will fit in just fine. In fact, there's room in there for that and also one of those little boards, so that will be fine. However, this one doesn't have any pins on it, so I can't plug it into a breadboard, and I don't have another spare. I've got 3 in the post which haven't turned up. So I'm probably going to steal the one off this project here, and this sort of frustrates me because I've had this project for a couple of years or so, and I've even gone back and watched the video to see what I actually did. So I keep meaning to actually finish this project off. I have an idea of what to use it for. It's basically an Arduino driving an old CD mechanism. But anyway, that will appear hopefully in a future project. Now a few other things on the table. I've got a speaker here. This is basically from a cheap pair of headphones. I've got some other speakers like this little one here, this one here. Now I quite like this one here actually because it'll fit quite nicely into the back of the sound box. So just stick on like so. I'll probably use a sort of rubber O-ring as a sort of isolator like so. With a bit of experimentation I've discovered that these rubber O-rings will super glue onto the PLA plastic I'm using. There's a test sample there. So that's what I intend to do with that. The other thing you may have noticed in the back is I have this remote control. That's because I'm going to make this infrared, and I've done an infrared project before. In fact, this is the very same remote control, but as I won't have the gramophone and my radiogram going at the same time, it doesn't matter that I'm using the same control for both. Anyway, the sensor for the remote control is there. I just steal these off older bits of equipment. That one's actually off a Skybox. So these are satellite receivers that's used in the UK. There's one there. You don't even need to desolder it. It's got legs which are long enough so it can just be clipped off, and because this shield here is actually grounded, it's easy enough to determine which pin is ground, and if you know which pin is ground, it's possible to determine which pin is 5V and which pin is the data. So I will probably mention that further. This is a Skyboard that I've actually taken the sensor off. This is the one that's actually on the board over there. I actually salvage these. I've got a couple of little packets of them, and essentially they either go, I think, output, ground and 5V, or output, 5V and ground. So I think the ground and the 5V are reversed around. So if you know which pin is ground, then you can work out which pin is 5V and therefore which pin is output. A few other things. I don't think it's quite in camera shot. Oh no, yes it is. The ribbon cable. Why have I got a big lump of ribbon cable? It's because I intend to run a cable from this box here out to the outside of the gramophone for the sensor, for the infrared sensor, and because ribbon cable is flat, it should go through the gap. There's a very small gap between the lid and the base of the cabinet, so that should go through there. And I'm also probably going to put a bi-coloured LED in, and so I will actually use 5 lines from this. So that would be 5V ground and signal for the infrared, and 2 lines to achieve the 2 colours on the bi-coloured LED. And again, that will go on a schematic at some point. What else? I think the only thing I haven't talked about is these little things here. These are basically cut down sockets. Because I've had so many problems with these DF player boards, that's not how you take them out, then I'm not actually going to solder them in. I'm just going to use these and solder onto the top of these. Because that way, that will allow me to make this video and actually get this unit running, and then if I want to, at a later stage, pull the DF player out, whichever one I choose to use in the end, and actually then do some further tests or maybe make a further video about it. It also means I can swap the different units around inside the sound box if I so choose. Okay, so how does one work out which pin is ground? So I've got my meter set on continuity, so touch the probes together, they beep. On this board is actually very simple because round the device is a piece of shielding, and that will be connected to ground. There's no point for it if it's not. So what I'm going to do is just hook a probe into the shield and then just check to see which pin it beats on. So which pin has continuity to this shield. So first pin, nothing. Second pin, beeps. Third pin, nothing. So that tells me that the middle pin is connected to the ground, or connected to the shield, which is going to be connected to ground. So therefore on this one it's the middle pin which is ground. Okay, so how do you find out what's ground if there isn't a convenient piece of shielding? Well, essentially it's a case of finding something else on the board where you do know there's ground. And on this particular board there is a chip on the back, and the chip is marked 4049, which is a common chip, easy enough to look up. And I happen to know that pin 8, and that is starting there because that's pin 1 there, pin 8 is there, pin 8 is ground. So it's a little bit tricky, but if I actually touch this probe against pin 8 and then repeat the test, so the outside pins do not have continuity and the middle pin does, and of course there's also continuity with the shield because we know that's connected to ground. But there we are. If you don't know where the ground is, then find something which has a fixed ground like a chip and look up its part number and find out which pin is ground and do it from there. Okay, so let's move a bit further forward. I've got it all built round a Nano at the minute. This is a Nano I nicked off that other project. I do have this one here which I'm going to use for the final version. I've added on the bidirectional LED as well, so as well as sort of tidying up the wiring, it's now got an LED for output. So if I just turn it on, it uses the LED as a self-test, and this speaker here is connected up. I'll show the other couple of speakers in a minute. And it takes a little bit of a time to initialize as well because it's having to faff around because of issues with this particular board. This board doesn't really work quite as well as it should do. So anyway, I can pause it, and every time that the sensor picks up a code it recognises, the LED gets flashed green. If it picks up something it doesn't recognise, it flashes it red. I can decrease the volume, increase the volume. I can skip a track. I can go back to the previous track. Okay, well I mentioned I've got 3 speakers out at the minute. I've got this one here, which is part of an old headphone or set of headphones which I've been using. It's okay, but it's quite high impedance, so it's not very loud. If I just unplug that, put this one in instead. Now this I think is an 8-ohm one, and it's fine, and it would fit in the case, but it's a little bit big. My favourite one is this one here. Which I think for the size is fine. and it's going to fit quite nicely. So that's the rubber ring that I'm going to use as a sort of isolator. And just in case you're wondering, this is all music which is copyright free, which I've downloaded from YouTube. Well, I've done a little bit more mounting up the MP3 player as well. As I said before, I'm going to use sockets. So what I've done is I've cut up an IC socket there and soldered it onto a piece of sort of pad board, I suppose you'd call it. And that's going to fit in here so that the SD card slot is visible, and then I 3D printed another bit of plastic that's going to go on top, a bit like that, but with a little bit more gap, and it's going to be glued onto the side of the case and then have a nut and bolt. Basically the nut will go on the underside, and then by screwing the bolt into, or screwing the machine screw into it, it'll push down hard on the actual pad board and just keep it in place. And I mean, I might use some double-sided sticky tape underneath as well, but essentially I want it to be held firmly in this case here, but also be removable, because I have several of these, and they all perform differently. They all just don't seem to be quite the same. They respond to different commands in different ways, or not at all, and I may want to switch them around at some point in the future, or get them all out for testing. So I've wired up the other Arduino, but without the LED and the infrared sensor, but it seems to be playing just fine. Well, it's done. I just wanted to show what my bench looked like. It's been a bit of an epic build this afternoon, lots of tools and components and stuff out, but it went pretty okay actually in the end. Normally I'd use my other workbench for electronics, and now I remember why, because to be honest, I got quite a bit of backache leaning over this one. Okay, so what have we got? Well, the Nano without any pin headers in I've used here, so I've just soldered the wires directly into the little holes. The MP3 player is in that little carrier that I made, so that again is just wired directly onto the Nano. I needed a resistor. It is on the original diagram, or the original circuit board, between the Nano and the MP3 player. This is on the transmit data, because basically the Nano is running at 5 volts. This will run at 5 volts, but it likes its data at 3.3 volts. So the resistor there is just to knock the voltage down a bit. Speakers connected there. That will go on to this rubber ring here. That will go on to this bit here, which is basically the back of the sound box, like so. Now the little sensor board here, this has got the bicolor LED there and the infrared sensor there. That's actually hardwired all the way through to the Nano, so it's actually going through a hole in the case. So I had to stick the cable through the case before I soldered. In fact, it was the Nano end. I did this end first. If I was doing this again, I wouldn't do it like this. I would probably just make some sort of cutout up here somewhere and make it so that when the lid was on, that sort of turned the cutout into just like a little slit. So I'd be able to take the lid off, or take the back off, and just remove this cable. That would make things a lot simpler. And I've got a bit of shrink, or heat shrink on the cable there. The idea is that at some point I'm just going to slide that over there. And just shrink it down. And if it doesn't work very well, I'll have to cut it off, but if it doesn't work very well, then I can't put another one on, because I've soldered it all in place. Just going to do a little test to demonstrate it working in this state. So if we increase the volume, should be able to see the LED flashing. Now I'm not going to go through all the functions again, but what I have done, if I just pause it, is I've actually modified the pause functionality. So it now does long, slow flashes between red and green when it's paused. This is so if I'm running off battery and I forget that I've paused it, I will actually remember to disconnect it from the battery before going to bed. Right, it's all together now. I just used hot glue. I didn't use this little bit of plastic. I discovered that there just really wasn't enough room to get the MP3 player out with this in place. So all I've done is I've just hot glued on the top of the board there. I'm sure I could remove that fairly easily with a pair of pliers or something if I need to take the board out. I've hot glued the Arduino in there as well. So both cases, so the connector for the Arduino there, so power goes in there, and if I need to reprogram it, and the memory card is visible there. And I did use some cheap super glue to glue the speaker to the rubber ring, but then I hot glued that in place and spread a bit more hot glue around. I actually had the thing running when I was gluing the speaker into place, just to make sure that if any glue did sort of seep where it shouldn't do, that these sort of vibrations of the speaker would hopefully stop it all just jamming up. But it seems to sound okay. So if I just wind it in to the box, or just wind this cable down so it fits into the box. Going to have it something like that, probably with a memory card like that in relation to the fitting for the tone arm and the power around here. Just sort of tighten these up a little bit. I've also put the heat shrink on the sensor board there, so I think it looks okay. It'll certainly do for the minute. So just power it up again. It really is quite loud actually. I might have to change the default volume on it. So that's the volume down a bit. But I think playing through the horn of one of my big gramophones, that's going to be plenty loud enough. So basically that's what I'm going to try next. Okay, so now time to give it a try. So first of all, I take off the existing sound box. Put that to one side. And then the new sound box is just here. So it just goes on exactly the same way. I've got the sensor cable, so a light and sensor cable here. I probably normally have it to one side, but for demonstration purposes there is fine. And it's powered by this USB cable going into this power bank. And with the remote control I can pause it and adjust the volume. But of course I can also adjust the volume by opening the doors, just like when playing a record normally, because it's going down the same pipe just as though the sound was coming off a record. And this being on a cable like this means that I can close the lid and still control it. Now I've checked the power consumption. It's taking about 20 to 30 milliamps when it's paused like this, and somewhere between 50 and 70 milliamps when it's actually playing music, depending on the volume. So even with a small power bank like that, which I think is 220, just check this, what does it say? 2200 milliamp hours. So with that, it's still going to last a good many hours playing without issue. And obviously, because it flashes when it's paused, the chances of leaving it plugged in overnight is now pretty slim. One last point. You will read, if you investigate this MP3 player, that there's all sorts of fancy naming conventions as to what to call the files and where to put them on the SD card. All I've done is just copy all the MP3 files onto the SD card just on the top layer. I've not used directories, I've not used any sort of naming convention. I've just put them all on, and it basically just checks how many is on the card and just random plays against that whole number. So nothing clever there at all. Okay, so that's it for now. Thanks for watching, and if you have enjoyed this video, please subscribe to Mr. Archie Stuff. Thank you.